determinants. Okay, this what is determinant? Okay, let's take a matrix of order 1. Okay, determinant is it's actually property of square matrix. Let's take a first order matrix. This is 1 by 1 matrix. Let's say this is A. So here det A is det of 2. We write like this, and it's 2. Okay, this is one property of a matrix. Simply you can say that one way. Let's say you have 2 by 2 matrix. 2 by 2 matrix. Let's say this matrix. Let A equal to, let in this case, let A equal to this matrix we have A, B, C, D. Okay. Then det A we write like this. Det A we write like this. Okay, 2 lines like mod A. Det A we write like det A is now det of A, B, C, D, and this we define as AD like this. This into this. A into D minus BC. Okay, first you learn this way. Okay, this way you learn. Later we can discuss. Later we can discuss in detail, but you learn this. Now this is simple. A into D minus BC like this. Okay, and then let A equal to, let A equal to, let's say this is A11, A12, A13. A21, A22, A23, A31, A31, A32, A33. Okay. Again, how do we write det A? Det A we write like this. Det A we write like this. A11, A12, A13, A21, A22, A23, A31, A32, A33. Like this we write. And how do we define this? See, det A, how do we define? First we write A11, A11, and you remove this row and this column. This row and this column you remove. Then what you have? You have this much. This row and this column. A11 is there, no? That row, that column you remove. That is what is left now. A22, A23 left, A32 and A33 left. We should write this determinant of this. Okay, determinant of this. And then next minus A12. A12 into remove this row and this column you remove. This row, this column if you remove. The element in which you have row, this second row, first row, second column you remove. Remaining you write in determinant. A21, A23, A31, A33. You write this. The next you have third element. So yeah, that means you say determinant you are finding by expanding the first row. First row you are expanding first row. A13. So this row, first row, third column you remove. Remaining you write in determinant. Okay, that is plus A13, and you write A21, A22, A31, A3. Okay, this is called. This is how we define third order determinant. This is 3 by 3 square matrix, third order determinant. We say this is third order determinant, and we define like this. This is just to say this is how we find. Okay, first exercise will be like this. But okay, but we'll discuss in detail what is determinant, how do you find it. Okay, here first for finding first we discuss first number 1 we need to discuss how to write determinant. Any matrix A is there. A is any matrix. A is any matrix. Okay, then determinant of A, det or det of A we say, that is we can write like this also. That is det of A, like this also we can write. Det of A. Det of A we write like this also. Or we can write det A, like this also we write. Okay. But A is any matrix, then det of A we can write, det of A we can also write, or det A we can write like this. That is determinant. 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 of A. Determinant of A, we simply write det of A, or det of A we can also write like this, or det A we can also write like this. Anyway we can write. Okay, det of A. Okay, this is det of A. And how do we define this det A? So for that, first we should know. So here, first we should know for this minor. First we should know minor of an element. Minor of an element. First you should know minor. Then second thing, you should know cofactor. We should define first, you should know definition of minor and cofactor of element in matrix. Okay, these two should know. Minor, I want to first teach you what is minor and what is cofactor of an element in a matrix. Okay, then later we define the determinant. How do we define the determinant? Minor and cofactor. Okay, let's learn that. So first, minor. Here, let A is any matrix of third order. Let's take third order. Any order, the same thing, but let's take third order. A12, A13, A21, A22, A23, A31, third row first element, third row second element, third row third element. So I am using all the time this only so that you will be familiar with this. Okay, it's very important to write this way. Okay, first row first element, first row second element, first row third element, first row third element, like that. So here minor of, so minor of A11, minor of A11, okay, is minor of A11 is written like this. Minor of A11 equal to M11, like this we write M11. Okay, M11, that means minor of first row first column element. Okay, M11 is the determinant obtained by removing, by eliminating first row first column. First row first column element minor. We want minor of first row first column element. So how do we get the determinant found by eliminating first row and first column? If you eliminate this first row and first column, what do you get? A22, A23, A32, A33. This is what is minor of A11. Okay. This is what is minor of A1. So already I told you, this is how do we define this? See, we define like this, A3. Okay. This is determinant of second order determinant. Second order determinant A22 into A33 minus A32 into A23. AD minus BC. Okay. This is what we do. All right. Then next, you can find minor of anything. Minor of, for example, A12 you have to find. You can find out minor of A12 equal to M12 and M12, that is minor of first row second column. So what you should do? First row you should remove. This first row you should remove. Second column you should remove. What you obtained is A21, A23. Okay. The determinant obtained by removing first row second column. First row second column if you remove, then you get A21, A23, A31, A33. Okay, this is what you get. So then how do we define how second already we discussed, right? AD minus BC. This is second order determinant. The second order determinant is defined like this, AD minus BC. So this A, by removing second column, first row second column, that is A21, A31, A23, A3. So A21, this into this, A21 into 3 3 minus a 3 1 into a 2 3. Hope you understand. Then minor of anything you can find. Minor of then this element. So let's say minor of this element a23 a23. Minor of a23 is m23. Minor of second row third column. So you remove second row third column. This is second row and this is third column. You remove, then what you have? Determinant obtained by removing second row third column. Okay, this is a12 and this is a31 a32. All right, a11 into a32. AD minus BC, that is A31 into A12. So this is what I think you understand minor. Like that, you can minor you can find out for every entry. Okay, here 9 entries are there. You can get minor for every entry or every element in the matrix. You can find out minor for every element in the matrix. That is what is a minor. Minor means what? Determinant obtained by removing the row and column in which the element present. Okay, element. Okay, jahan bhi hai element, so that row, that column we have to remove in which the element is present. Here a11. So first row, first column we remove and determinant obtained by removing first row, first column. Like that we find. Hope you are clear with the minus. So then we go for cofactor. So cofactor of an element of a determinant. Okay. So let's say again A is there. So then cofactor we write like this. Cofactors we write with capital. A11 with capital A we write. A11. A11 is, this is the formula. Cofactor. Ith row, jth column. Cofactor of ith row, jth column, let's say. So minus 1 to the power of I plus j into minor of ith row, jth column. So for minor only we have to minus 1 to the power of I plus j, you should multiply, that's it. So A11 means what, you know, minus 1 to the power of 1 plus 1 into M11. That is what? M11 only. And then A12, that is minus 1 to the power of 1 plus 2 into M12. That's what is minus M12, like this. A13 is minus 1 to the power of 1 plus 3 into M13. That is what is M13. Okay, this is the difference between cofactor and minor. So that means if you are able to find out the minor, then you will be able to find out the cofactor. Okay, very simple like that. Right? So
yes, sir.
We'll take an example and then we'll find out minor and cofactor. Let's take an example. Let's say determinant is here, the matrix is given 1, minus 1, 3, 5, 2, 4, 0, 1, 5. Okay, this is what is the. So let's find out minor and the minor. Okay, minor. So I am finding minor of first row, first column even. M11, that is minor of first row, first column. So for this we have to find out the minor, means what row and column we have to remove. Determinant obtained by removing first row, first column. To remove first row, first column, first row, this is first row and this is first column, you get 2, 4, 1, 5. Okay, then what is the minor? 10 minus 4. AD minus BC. 2 into 5, AD minus BC. Determinant of second order determinant, AD minus BC. So that is what is 6. M12. What is M12 here? So second row, sorry, first row, second column. First row, second column. You remove first row, second column, 5, 4, 0. So that is what is 20. So 5 into 5, 25 minus 0. It's 25. So M13. Similarly, M13. First row, third column. So 5, 2, 0, 1. This is what is 5. Next M21. M21. What is M21? Second row, first column. Second row, first column. If you remove what you get, minus 1, 3, 1, 5. So that is minus 5, minus 3. minus 1 into 5, AD minus BC, minus 1 into 2, minus 8. And AM, 2, 2. Second row, second column, you remove 1, 3, 0, 5. And this is 5 minus 0. This is 5. Hope you understand like this.
Yes, sir.
So then we can find out cofactor. So cofactors. Cofactors also we can find out like that. Let's say we have to find out cofactor for. Let's say we have to find out cofactor for. Let's say A12. Okay, A12. How do you find? Minus 1 to the power of 5 plus j. 1 plus 2 into M12. Simple like that. So that is minus minus 25. That's it. So that's the only difference. So you may get minus or plus. Cofactor is like that. Okay, now determinant. 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 How it is defined? Determinant. Determinant. You can. Determinant is sum of product of any sum of product of elements of any row, sum of product of elements of any row or any column, even column, any row or any column with their cofactors. Understand? Sum of product of elements of any row or any column with their cofactors. So that is, I will tell you what is that. That is first row. Okay, you can first row elements if you multiply with their cofactors and then add. That is A11 into A11. First row element you multiply with its cofactor plus C sum of, this is sum of product of elements with their cofactors. A12 plus A13 into A13 like this. This is first row elements, right? I multiplied with their cofactors A11, A12, A1. Or you will get same. This is data. Same data you can get by second row. A21 into A21 plus A22 into A22 plus A23 into A2. Like this. A23. So R data is, you can write A31 into A third row. You can expand with third row also. A32 into A32. A33 into A33. I expanded. This is with respect to first row. This is with respect to first row. First row. Okay, with respect to first row, that is R1. This is with respect to second row, R2. This is with respect to third row, R3. That means what you can expand, determinant you can find out with respect to first row or second row or third row. Or even first column, data you can write also like this. A11 into A11 plus A21. This is second row, first column. That is first column with respect to first column also. So you multiply first column elements with their corresponding cofactors. A31 into A31. This is also determinant. That means what? 6 ways. 6 ways total. Why total 6 ways? Because you have 3 rows and 3 columns. With respect to 3 rows also you can find out. With respect to 3 columns also you can find out the determinant. Okay, this is not only first, this is third order determinant. Second order also like that only. So for example, you have this. You have A, let's say you have 2 by 2, 1, 5, 3, let's say. So here also M11 will be there. Okay, for 2, what is that? Depth of 3. That is 3 only. Okay, so minor of 2, that is minor of 2 is what? Determinant obtained by removing first row, first column. This is the first row, first column is det 3. Det 3 is 3. Minor of 1, 2. What is minor of 1, 2? First row, second column. So what is that? Is det 5. That is 5. M, this is not mod. This is not mod. This is not mod. Understand, this is not mod. I'll keep minus for the tree. This is not mod, this is determinant. Okay, M21. M21 is what? Second, this is second row, first column. This is second row, first column. That is det minus 1. Det minus 1 is what, you know? Minus 1 only. Det of A is A only. That's what I told. First order determinant. M22. Okay, minor of 2, 2. Second row, second column. Minor of second row. That is minor of 3. For 3, what is the minor? Det 2. That is 2. Okay. Then cofactor, I am finding cofactor. Okay, minus 1 to the power of 1 plus 1. Okay, into M1. That is what is minus 1 to the power of 2 is minus, that is plus only. We can directly write this is 3 and A12, this is minus M12. I am writing directly minus because 1 plus 2, 3, minus 1 to the power of 3 minus 1. No, this is what is minus 5. A21 is, this is minus M21 and this is minus of minus 1, that is 1.
Actually, I have a doubt.
Yeah.
So you wrote M12 is equal to 5, like determinant of 5.
Yeah, correct.
Shouldn't it be determinant of minus 1?
M12 is minor of minus 1. Okay. That is.
So, but while writing, you wrote M12 is equal to determinant of 5, no?
No, that's what I'm telling.
So now I got it. I understood.
Yes. This is minor of 1, 2. First row, first column element. Iska minor. So the minus 1 minor is, that is det 5.
Yes, sir. Now I understood.
So then minor of 2, 2, minus 1 to the power of 2 plus 2, that is plus M2, that is 2. Okay, now det is what we know, the same thing here. A11 into A11 plus A12 into A12. You understand? A11, what is A11? 2. A11 is what? 2. And it's cofactor. What it's cofactor? 3. Understand?
Yes. Sir.
A12 is what? Minus 1. What is its cofactor? Its cofactor is minus
5.
Its cofactor minus 5. Like that. So this is AD. Understand? It's the AD minus BC. What is BC? AD minus BC. Minus 1 into 5. Understand? This is AD. This is BC. Minus 1 into 5. This is BC. Understand? Like that only we get AD minus BC. Hope you got it, right?
Yes, sir. Got it.
Like that. Determinant definition is this. What is that? Sum of, what is that sum? Product of elements of any row or any column with their corresponding cofactors. Their cofactors we can say. Okay, then we are multiplying element. Okay, first row we are taking. This is the first row. First row elements. We are multiplying with their cofactors. And then you are adding. You are adding this. So that is the sum of the product of elements of any row or any column with their corresponding cofactors is what is determinant. That is, so that's why here, so for first order, what is there? First order direct. So first order, it's direct. For second order, we can apply the definition. But anyway, this is easy to remember, therefore AD minus BC. For third order, first element its cofactor, plus second element its cofactor, plus third element its cofactor, or this second row. Second row also same thing. Okay, 2 into its cofactor plus 2 into its cofactor, 2 into its cofactor. Or you can take this column also. First column elements into their cofactors, or second column into their cofactor, third column into its cofactor. You will get all same. Determinant you can find out in 6 ways. What are the 6 ways? 3 rows you can use or 3 columns you can use. You get determinant say. Okay, that's what is the determinant.
Yes, sir.
Okay, so we'll do. Okay. Yeah, so here, why this determinant we have to find out, that we'll discuss later. Because see, matrix, what is the application of matrix? One thing I would like to say, matrices are matrices. We can say matrices. Many people say matrices. We can say, English. It's not a very ideal language. Some people pronounce in one way and other people can pronounce another way, and whatever way you pronounce is correct. Okay, matrices are matrices, whatever. So matrices and determinants. So these both are no, of course, so only one topic. Okay, consider one topic only. Matrices and determinants. Okay, their application is to solve linear equations in system of linear equation. You can write system. System means what? Means set of equations. Linear equations. Okay, system of linear equations means what? That two variables, two equations in two variables. System of equations. System of linear equations in two variables. That means two equations in two variables. So that you can have 3 variables and 3 equations. System of linear equations in 3 variables, we say. That means what? You will have 3 equations. So how do you solve it? Okay, that's what is the application here. So here you have a C here. A1 x2. This is system of linear equations in 2 variables. We say system means what? 2. One equation we don't call system. Okay, like this. 2 variables means what? 2 equations we have. That's called system. System of linear equations in 2 variables. System of linear equations in 3 variables means what? 3 equations we have. To solve that, we use matrices and determinants. That's a final application of matrices and determinants. By applying matrices and determinants, you can solve linear equations, system of linear equations, either 2 variables or 3 variables or 4 variables or 5 variables. Actually, this makes easy. Okay. So that's a final thing. Okay, for that we need to learn now determinant. How do you find determinant? That's it. Okay, right, all right. So here we'll see now. So we discussed determinant of a matrix of order 1. Order 1 is directly defined. Det A, that is A. So we discussed that one. Here AD minus BC I told you. And determinant of the third order matrix, for this I gave detailed explanation. But here expanding along with first row we told, okay, that expanding with respect to first row, this is like finding what? This is like finding cofactor. So first cofactor we have to find out, then determinant of det A. What is det A? First 2 elements with their cofactors. Or you can find out other way also, expanding with respect to second row. So we discussed all this. Expanding with respect to first column, second column, third column, and then examples. Hope you got this. Okay.
Yes, sir.
Okay. So you finished now. This one you finished, right? Evaluating the determinants, and this one you got, I think, right? Shall we do 4th question or anything?
No, sir. We finished all the questions in the school.
Okay.
No doubts.
Okay. Shall we go for properties of determinants?
Yes, sir.
All right. So here, very important one property is there. What is that? You see here. Here, what is the
Sir, if
property?
it is 3 by 3 matrix, then 3. I don't know how to explain it, but the determinant of 3 is equal to 3 to the power 3 into determinant of A.
Very good. Exactly. Here, det of 2A is 2 square into det A. Because here, when you are expanding, what will happen is here, this 2, you are multiplying to 2 rows. But when you multiply it, you have to multiply 2 rows, 2 into 2, 4 you will get. Here, you have to multiply to 3 rows. Det of 3a is what? 3 to the power of 3, because you have third order. 3 to the power of 3 into det a you get. Det of, let's say, k, what you get if nth order, k to the power of n into det a. This is what is the important property. Okay, that's what first we are going to see that. Okay, one important property we'll see. Very important property. So properties. That's already there, therefore I'm showing that. Properties of determinant. Property of determinants. First property. Det of Ka equal to k to the power of n into det a. Or third order n equal to, that is, what is that? That is third order. Third order det. Okay, third order determinant, let's take. Okay, third order, if you take det of k equal to k to the power of 3 into det a. Okay, this is what we get. Okay, why? Why? Because you see here, let's take k equal to, let's say a equal to 1, 2, 5, 2, minus 3, 4, 5, 0, minus 3, minus 1. So I am expanding with respect to, yeah, this is what is a. Okay, this is what is a. Now, what is Ka? What is Ka? You tell me. Each element you have to multiply. Matrix, when you are multiplying to matrix, you have to multiply to each element. So that is K, 2K, 5K, like that. So 2K minus 3K, 4K, and then 5K, 0K, and minus 1K. Yes, sir. Now you got this, yes, sir. This is what is matrix multiplication.
Yes.
K
Sir.
into matrix. But det of K, you understand, det of K is what? Det of K is, so K into, and its cofactor. Its cofactor is determinant obtained by removing that row, that column. 4K, hai na? 0 minus K, hai na?
Yes, sir.
Plus 2K into, here you get minus, na? 2K into first row, second column, minus 1 to the power of first row, second column, hai na? So you get minus,
Yes.
therefore that minus I will put here. Minus I will put here. And this is 2K, 4K, 5K, minus K. And then next 5K into its cofactor. Minus 1 into 1 plus 3, 4. That's the reason I plus it. The alternate plus minus will come. 1 plus minus plus. So this is what is removed, that row. This row and column. This row and this column. That is 2K and 4K and 5K and minus K. Okay, this is what. You see here, what you get is K into, here minus 3K into K, 3K square minus 0, minus 2K into, what you get here, minus 2K square minus 20K square, plus 5K into minus 2K square minus 20K square. See, all K cube is coming, no? Here K square, everywhere K cube is there. That is this into this you multiply K cube, everywhere K cube will come. Yes or no? Or you can take K common. I'll write in the next page. Det of
So
K.
can you go back to the previous page one?
Yeah. You see everywhere
Sir,
K.
there is 5K. Shouldn't it be determinant of 2K minus 3K, 5K and 0?
Yes, sir. 5K, yeah. 2K minus 3K, 5K is there. Minus 3K. And 0, yeah, that's true.
Yes.
Remove this row, this column, 2K minus 3K, 5K. Yeah, that's true. So that's what I'm saying here. 2K, this is 0, 0, and this is plus 15K square.
Yes, sir.
Yeah, this is 0 plus 15K square. So, yeah, one thing is that you can take K common. So K common. First thing is k common and you can write. Then one more k will come, that is k into k square will come, and then you write this. That is what is k cube into death k only will come there. If you do it carefully. Yes or no? Yes, sir. This is, if you take k square common, 3 into 1 minus 0 into 4. K square common. Here if you take k square common, what you get? 2 into minus 1 and the next 5 into 4. K square common. K square common like that.
Yes, sir.
Yeah, that is total k cube into death k only you get.
Yes, sir.
Hope you understood this.
Yes, sir.
Yeah, this is what is property 1 I wrote. Property 1 I wrote. Okay, any order we can go. Same property 2. Okay, if entire row or entire column has all zeros, then determinant will become if entire row or column has all zeros, then that is 0. Yes or no? So like this,
Yes, sir.
like this, 0, 0, 0, 5, 3, 2, 4, 3, 1, whatever. This determinant is 0. Entire column is 0. That means you are expanding with respect. 0 into its cofactor, 0. 0 into its cofactor, 0. 0 into its cofactor, 0. You understand any row or any column. If entire row or column has all zeros, then data is 0. Hope you understand this. Any row or any column.
Yes, sir. Understood.
Okay, that is okay. Then 3. If a row or column has a constant column, then we can take that constant common to the debt. Okay, this I'll explain. It may not be meaningful. So let's say here you have k, 2k, 3k, 5, 6, 4, minus 2, 1, 0. Let's say you have this. What I mean to say is k is common. Entire row k is common. You can take k common to the determinant like this. 1, 2, 3, 5, 6, 4, and minus 2, 1, 0. Why you know? Why you can do this? Because here determinant, if you expand, what will happen? K into its determinant, yes or no? K into its cofactor plus 2k.
Yes, sir.
Yeah, just I'll write again. K into its cofactor A1 to A1. Plus 2k
Yes, sir.
into its cofactor A12 plus 3k into its cofactor A13. So the next step, what you can write, k you can take common, A11 1 into A11 next plus 2 into A12 plus 3 into A13. That is what is this SR. K is common, then like that. So that means what? Any entire row, if any row entirely a constant is there, you can take that constant. That means what? In matrix you can't do that. In matrix, you don't get confused. In matrix, you can't take common from a row or a column. But you can take in determinant, you can take a row or column. You can take common from a row or a column. So in this row, you have k common. So you can take k common out of the determinant. Okay, this is possible only for determinant, not for matrix. Matrix means what? Whether you multiply, you can, if you want to multiply k, you can multiply to any row or any column. You want to multiply a constant k to any row or any column, because when you expand with respect to that row, that column, k anyway comes. I think you understand this, right?
Yes, sir, understood.
Because see, for example, now in this guy, you can, what you can write is now k, you can do it. 1, 2, 3, then 5k, 6k, 4k, then -2, 1, 0. You know how this comes? This comes because of definition. Because you know this k into this delta, this k into delta. So this delta, what you can write there? Delta you can write this also, no? 5 into its cofactor. Yes, sir. This 5 into here 5 into its cofactor. Second row also you can expand with respect to second row. 5 into its cofactor a2 plus 6 into its cofactor a 2 plus 4 into its cofactor a 2 3. Yes, sir. No? This is delta only, na?
Yes, sir.
Then what you can do? 5k a2, then 6k a2, then 4k a2. Yes, sir. So then what you can say here? Then what you can say is this is second row. So you can multiply like this. This gives you this. That means what?
Yes.
In determinant, if at all you want to multiply a constant, you have to multiply to any row or any column, you can multiply.
Yes, sir, got it.
Okay. Okay, then we'll go back and check this. Oh, what I would say is now k into a11, k a12, k a13, and then you see k a21, k a22, k a22, and here k a31, k a32, k a33. And determinant. So now you know this is what is delta of Ka. Yes or no? This is delta of Ka. Yes or no?
Yes, sir.
From first row, see here, from first row you can take common K. Yes or no? From second row into second row you can take common. Third row you can take common. Yes or no? From entire row we discussed, previous discussion was
yes, sir.
From entire row you can take common. No, K is present in entire first row, so you can take common from entire first row, second row, third row. This is again A11, A12, you can write this all. And so K cube into to delta. So delta of Ka equal to you can prove like this also. Delta of Ka equal to K cube into delta. Like this also
yes,
can prove.
got it. We can prove it this way also. Yes, sir.
Okay. Next 5. This all comes from what definition. Yes or no? These all properties are, if you understand definition, then these all properties you can understand. Okay, got it right?
Yes, sir.
The next, what is next? If 2 rows of any determinant, 2 rows of any determinant are identical, then delta is 0. That is say for example A B C, ये वाला तो A B C, here P Q R. What you say here? This is delta is 0 as R1 and R2 are identical. Identical means what? We will have the same element ABC. This is called identical. Two rows identical. Now that is no see to see this to see expand with respect to third row. Expand with respect to R3 which is P into its cofactor BC minus BC 0 है ना P into its cofactor BC minus BC 0 yes or no P का
Yes,
cofactor
sir.
remove P remove this row and this
Yes.
column you remove then what you get BC so B into C BC minus BC 0 Q into its cofactor AC minus AC 0 R into its cofactor AB minus AB 0 okay
Yes.
like that other way also you can understand other way also you will get zeros. Okay, is that okay?
Yes, sir.
The next. If any two rows or even columns, any two rows or columns of a debt are proportional, then debt is 0. That is like this. Here too, I'll write PQR. So here A, B, C. Here KP, KQ, KR. This is the meaning of proportion. Now here this is 0 as row 1 and row 3. Row 1 and row 3. Row 1, row 3 are what? Proportional or not?
Yes, sir, they're proportional.
So what? How do we understand this? Expand with respect to row 2. Okay, to see expand with respect to R2. If you expand with respect to R2, what will happen? A into its cofactor क्या होता है? R है ना? ये वाला तो ये रो हो गया ये. So Q KR here also Q into KR minus KQ into R.
Q into R.
Same thing है ना?
Yes, sir.
So 0. You understand?
0. Yes, sir.
Okay, this okay. Actually, we discussed only 5 properties. So I think